Hi guys, welcome back to the channel. So in this video I'm going to give you a few points which you can consider while buying a TIG welding machine for yourself, and also a review about the machine itself. So recently I purchased a Chinese AC/DC TIG welding machine, and as you can see that the box has already been opened because I already checked all the goodies inside the box. The machine did not belong to any particular brand, and I paid around $550, around 40,000 Indian rupees for the machine. And the main motive of this video is to show you a few points you need to consider while buying a machine, and to also convince you that you really did not need expensive machines to make better work, because in the end it's you who is responsible for the welding, not the machine. And if you practice enough, then no matter what machine you are using, the end result will be flawless. If you have a good money, then I definitely recommend you to go with a brand like Everlast, ESAB or Lincoln. But being a beginner, believe me, these Chinese machines are a good option for you, and their reliability is also good. In the welding machine, there are a bunch of different options like multi-process welding, and the one which are particularly made for a particular type like TIG, MIG or a stick. And if you are a hobbyist person, then you can definitely go and grab a Chinese multi-process welding machines, but do not expect too much features from those machines. And the machine definitely come with 3 different options, but not give you feature. While on the other hand, if you go with the brands, then they are feature packed but a lot more pricey. So if you're like me and wanted to go in a production, then definitely invest the money on a particular single type of a machine, and try to get as many features as you can. And this is the only thing you should consider. For this video I show you features of this Chinese machine which I bought. So the box contains 3 things: the TIG torch, ground clamp and the machine itself. Along with these things I also bought a gas flow meter and a pressure gauge. Many companies provide foot pedal and other accessory, but they don't come with this machine. Despite that, the torch comes in this kit having a switch onto it, and there is also a knob onto the torch, which means that I can also control the gas flow from the torch also. So this is an AC/DC TIG welding machine with the IGBT technology, and this is capable of handling the current up to 200 amps. And if you wanted to do the stick welding, you can also do that with this machine. IGBT is the newest technology, and they are the voltage control device, and the advantage over the MOSFET is that they can handle the power much better than the MOSFET type welding machines. Now you can definitely go with the MOSFET machine, but all the parameters you need to set with the knobs provided on those machines, because they are analog type machines. In the case of IGBT, like this machine, all the parameters can be easily configured with a better accuracy because everything is shown digitally. The torch in this was actually a WP19 model, but I decided to replace it with WP26, and this have a control knob onto it so that I am able to control the gas with the torch itself. But the stock torch is absolutely fine and less bulky than this. And to connect it with the cylinder, you also need a gas pipe. The pressure gauge comes up in 2 different variants, like the one I have having 2 different gauges attached to it. One tells the cylinder pressure and the other tells the outlet pressure. Usually it kept around 2 to 3 bar, and the flow meter needs to be attached separately in this case. The flow meter usually set around double the size of the cup. Like for number 6 cup, you need to set it around 12 CFH and so on. The second type, in which the gauge comes along with the flow meter attached to it. So both of them are good. To attach the flow meter, I use a thread tape to avoid any gas leakage. So this is the argon cylinder. I also tape the thread with the thread tape to avoid any gas leakage, because metal to metal connections are not trusted. Once the gauge is connected, the gas pipe is connected with the flow meter and also to the back of the machine with a hose clamp over it to avoid any gas leakage. So now I'm going to set the gas pressure and also the flow meter according to the cup I install on the torch. So along with all of these things, I also spent some money onto a gas lens kit. If you are willing to make a good weld joint, then definitely go and grab one of these gas lens kits. So the kit comes with bunch of different cup sizes and also with different sizes of collet for different sizes of tungsten. So this is the standard torch, comes with a simple cup, collet and collet body. The back cap is same for both the gas lens kit and the normal torch setup. In this video I'm going to work with the gas lens kit. So now I'm going to dismantle the torch so that you are able to compare both the setups. So this is how the standard part of TIG torch look like. The tungsten I am using here is 2.4mm thick. Now you can take a look at the design of the gas lens collet body. There is a wire mesh inside it which helps to maintain the laminar flow of the gas and helps more coverage over the weld joint and the tungsten itself. You can also see the difference between the collets. The gas lens kit comes with the Pyrex cup and the ceramic cups. The installation is pretty simple. Replace the front ring with the one which comes along with the gas lens kit. And if you wanted to use the Pyrex cup, then use the O-ring. And if you are using the ceramic one, then just thread it over the body. From the back side, you can insert the collet and the cap. The cap needs to be kept loose once the tungsten inserted inside. Tighten the cap and you are good to go. The stick out of the tungsten should not be more than the diameter of the cup, and once it's done you are ready to go. Installation of the machine is extremely simple and everything is clearly labeled onto the machine itself. So this is the user interface of the machine, and from here you are able to control the machine. There are few things which would be good for you to understand here. So onto the left side we have few parameters written onto the machine, and by pressing them you can switch to a particular setting. Onto the right side we have a knob with which you are able to change the desired value of that particular setting. Now the top left corner have three different parameters: output, arc and weld. The output have two different options, DC and AC. Normally for the material like mild steel, stainless, titanium, DC welding is preferred. Normally in DC welding the current goes from torch to the welding surface, while AC welding done over aluminium, and as the name suggests the current alternates both up and down. That's why a cleaning action also takes place in AC welding, which also increase the penetration into the metal surface. So if your machine have both these features, it means you are able to weld aluminium. Now under that we have an arc and have three different parameters: 2T, 4T and repeat. In 2T mode, when you press the button, the arc start up to full potential which you set up, and when you release the button it completely turned off. But in the 4T mode it's completely different, and in this mode the bottom shown parameter took important role. Suppose you set the initial arc at 20 amps and the welding arc is at 60 amps. When you press the button in 4T welding, the arc initiate at 20 amps and it will stay at that amps until you release the button. When you release the button, the arc reaches to 60 amp, which is the maximum current we set, and start the welding. And when you again press the button, the current again drop to the ending amps, and when you release the button, the arc ends. So in the case of 2T welding, the press and the release action of the torch performed once in a time, while in 4T welding it has to be performed twice. So that's the only major difference between 2T welding and the 4T welding. The repeat is similar to the 4T function, but only change is that after the ending the arc did not turn off, and instead of that the cycle repeat again to arc start and so on. The next we have a weld, and it have a three different function: no pulse, pulse and MMA. Now MMA used for the stick welding only. For no pulse, the arc initiate and you can start the weld according to the method you set, either 2T or 4T. For the pulse operation, the peak current, duty, pulse and base current are going to be considered. The peak current is a maximum current goes up to which the machine is set up. Then we have a duty, which means that the watt percentage that a maximum peak current is used for welding. Suppose the duty is set to 30%, and when we use the machine for around 10 seconds, then only for a time period of 3 seconds the maximum current is active, which is the peak current, while remaining 7 seconds the current is kept around the base current, whatever we have set it in our machine. The next we have the pulse, that how many times the machine pulse in that particular second. Now usually in high-end machines this pulse feature have two different types, high pulse and low pulse, but this machine only have a low pulse mode, and it can pulse around 25 pulses in a second. Now if you are able to get a machine with a multiple pulse mode, then definitely consider that over this machine. Then we have a base current, which means that what is the lowest set current during a particular weld. To explain, the bottom chart is like the pre-gas, has the gas come out of the torch before the arc initiate. Do not cap the pre-gas for longer duration as it's a complete wastage, but the 0.2 to 0.3 second would be good. Then we have a arc start, which only being utilized during the 40 operation. Time up is the time took by the initial arc to reach up to the maximum amps you set up in the machine or the welding current. Cleaning offset and the AC frequency is only going to be active when the machine is set up in the AC mode. Telling about the AC frequency is the number that the current will alternate in a particular second. The AC current alternates up and down, which means the current goes in both directions. That's why the cleaning option is provided, which means that some amount of current can be used for cleaning the oxide layer. Now more will be the cleaning action, more time the current moves towards the torch, which is not good for the torch and the tungsten itself. Now in this particular machine the cleaning cannot be set for more than 50%. Then we have an offset value which can set up to 30%. Offset is the ratio between the welding current and the cleaning current, and if you kept the cleaning low and increase the offset value, then penetration is high and the tungsten is going to spoil less. Then we have a welding current which active when you are in no pulse mode, and also if you are using a stick welding. Then the next is the pulse zone, which only active when you are in a pulse setup, which we discussed earlier. The time down is the time taken by the welding current to reach to the ending current. The last we have the gas delay, which means the amount of time in which the gas remain coming out of the torch. And this is usually done to prevent the tungsten from oxidation, and setting it too low leads to the formation of oxide layer onto the tungsten. And if you are going to weld with a dirty tungsten, then the welds are not going to be look pretty. So keeping it around 5 to 6 seconds would be the ideal time, and more of that is depend upon your particular usage. So that's pretty much all about the machine basics introduction. The one good thing about this machine is that the parts are readily available and the repair is much easier to do. The IGBT are covered with a bigger heat sink, and if in nearby future if something goes wrong, then I don't think it's a big deal to find out the fault other than the main card. And there is a gas relay valve at the back which rated up to 8 bars, and if the pressure is set more than that, then the valve become disabled and you have to remove the gas pipe to make it work again. Now I'm going to show you the different welds and all the different options which are described earlier. So let's jump on to that. So that's pretty much all about this video, guys, and I hope this video will encourage you to buy your first TIG welding machine and help you to step up into a world of TIG welding. Along with this video, I also changed the design of the machine a little bit, so if you are interested in that video, the link is in the description section. And I'm also working on to a stainless steel welding cart, which is going to be uploaded pretty soon. And if you like this video, then hit the like button, and if you're new to the channel, consider subscribing. Till then, be safe, have a happy welding.